Hello, I wanted to give you a quick overview on Remote Sensing 1 and Geography 243 for winter term 2020. Last week we have done a number of things, actually today, because we're posting this early on Sunday, for reasons that I mentioned last week. If you need to go back and review the overview from week 2. We finished Activity 1 this evening at 6 p.m. Some of you have already finished, I'm sure. And we also had some content last week on the first part of the chain of events that results in remote sensing, digital remote sensing of Earth's surface. This included some discussion of energy sources, typically the sun, but not always. We have passive and active sources of energy in remote sensing, much like our cell phone cameras have passive and active sources of energy in their remote sensing. The passive being sunlight or artificial light inside, and the active source of energy would be a flash from the camera. So there's an analogy between cameras that we have and active and passive remote sensors that we use in remote sensing. So energy sources, and then what happens to that energy is it passes through the atmosphere, absorbed, scattered, transmitted. And then what happens when it strikes the surface of the Earth? What are the different things that can happen? It can be reflected or absorbed and then emitted later, or it can actually be transmitted through transparent media like water, mainly water. That's what we're referring to sometimes penetrate to fairly decent depth in water and give us information about the subsurface or subaqueous surfaces that you can see in many shallow coastal areas. And then this week we're going to continue with a bit of that and looking at a couple of things, going into the second part of the diagram and taking a closer look at the Landsat program, the history of the program, where it came from up through about Landsat 7, and then, as you know, we're working with Landsat 7 and Landsat 8, some of us working with Landsat 5. Really the whole catalog from Landsat 4, 5, 7, and 8 was open in this first activity. Very similar sensors, but have changed somewhat through the years. Landsat 8 has been around since 2013. It has a few more channels. Different name for the sensor. It's very similar to the thematic mapper, and it can be used with data from the thematic mapper, the TM, or enhanced thematic mapper, the ETM, on Landsat 7. And so there's also so there's two different sections to the presentation this week. There's a section on Landsat, as I mentioned, and then the second section is just a real short discussion of histograms and data distributions in image data. So some of us have worked maybe in statistics with histograms and with data distributions, which is a special kind of graphic that we use to portray the character of sets of data. And so we use histograms quite a lot in remote sensing to characterize the distribution of reflectance or emittance data from across the range of possible values in in that whatever that data set has within it, whether it's 8-bit or 16-bit data. Those are the most common scales that we use in scaling our digital data these days, certainly with Landsat data. And so we also have some media that's available. There's actually I want to show you just a quick example of this. There's if I can find it, get it started here. is the Earth Now Landsat image viewer, and this media gives us a chance to browse and look at some very current and sometimes even very near real-time data for Landsat data. So here's the Landsat Now or Earth Now Landsat image viewer, and there also are other satellites that we can view with this. This is a Landsat 8 data set, and you can see this imagery, whether it's a recording. This is a recording from, it's near real time, but it is a recording from earlier today where data is being collected in, looks like it could possibly be, it's hard to tell from the map diagram here, but there are some islands here: Pico Alto, Orta, Angra do Heroísmo. This may be off the coast of South America. This could be possibly in the Galapagos. I don't know. It's a good question. So you can kind of play trivia games as you're watching this, and you can look at recordings from different different parts of the Earth, different satellite systems, and look at real-time data as it's coming in. It gives you a real appreciation for the speed that these data come in at, but also the volume of information that's coming in. Landsat information is being collected with Landsat 8. It's being collected at a rate of approximately 2 gigabytes every 20 to 25 seconds or so, 24/7 pretty much. So certainly on the daylight side of the polar orbit that Landsat has, it's collecting data at a really rapid rate. So it's piling up. We need lots of analysts to be able to work with these data to to help people out and to answer questions that we have about Earth and about what's going on Earth. And then later this week, we're going to, on Thursday evening, I'll release the Activity 2. In Activity 2, we do a technique that's really a manual classification technique using Landsat 8 data in this case, and using one of the thermal channels from Landsat 8. And we'll take a look at the coast of Honshu, Japan, and the Fukushima 1 and 2 nuclear plants, and take a look at some imagery from before. And then I'm going to challenge you also to actually do some analysis, analysis of those images using a technique that we call density slicing, that we'll use to isolate and view the thermal plumes from those two nuclear power plants that were operating on the coast of Japan before the tsunami, earthquake and tsunami in Japan a few years ago. And so then, I'm going to challenge you maybe to take a look at some more contemporary images, Landsat 8 images of the coast. We're going to use Landsat 7 imagery, I believe, for the pre-earthquake analysis of the thermal plumes, and then use Landsat 8 to look at what these sites look like right now. And this will be something that you'll be able to do a little bit of comparison between these two, and also learn a new technique, how to do the analysis of thermal plumes. Typically, these are done around power plants, big industrial plants, or some places where they're using a lot of hot water, and using big bodies of water like Lake Michigan, for instance, as a heat sink for all of this heat that they have to dispose of. It's like any type of, in some ways, any type of pollution where they're actually putting something that's a characteristic of the material that they're working with or the processes that they're working with. They're putting it into the environment, in this case, typically into the water. They use water to cool, and then they dump that hot water into, into large bodies of water, more or less using it as a heat sink. So that's what we're going to be. I'm going to be releasing it on Thursday evening, and I'll send you an email. That's the current plan. I'll send you an email that gives you, lets you know that that's been posted. And then next week I have a short presentation on Earth remote sensing data access. We have a number of things that are coming up. We do have our quiz 1 in, I believe it's in week 5. So next week is week 4. And also we're going to begin taking a look at final projects and start thinking about final projects, because we're on this accelerated quarter schedule here. So we only have a certain amount of time to get through a fair amount of material here in this course. Next week, or this week actually, density slicing, working with thermal data that is emitted energy. It's not reflected. It's emitted from the surface, and then also learning this technique of density slicing, where we take out a small part of the image and we focus on that particular part and able to look at it in great detail regarding temperature, both ordinal temperature, and then also raw, centigrade or Fahrenheit temperature as well. So week 3,